The injection actuation system takes lube oil from the main oil gallery and pressurizes it to power the HEUI injectors. This system takes the place of the gear train, camshaft, and rocker arms used to power mechanically actuated unit injectors. The injection actuation system has two main functions. It supplies high-pressure oil to power the HEUI injectors, and it controls the injection pressure produced by the injectors by changing oil actuation pressure. The injection actuation system has 5 basic components. The engine lube pump takes lube oil from the sump and pressurizes it to about 40 psi. The pressurized lube oil fills the engine lube circuit and provides supply oil to the hydraulic pump that powers the HEUI injectors. The engine oil filter removes soot and abrasive contaminants from the engine oil to prevent damage to critical engine components such as bearings and piston rings. The hydraulic pump pressurizes engine lube oil from 40 psi to between 870 psi and 3,500 psi to power the HEUI injectors. The IAP control valve returns excess flow from the hydraulic pump to the sump in order to control pump outlet pressure. The IAP sensor detects actuation pressure present at the HEUI injectors and sends a signal voltage back to the ECM. This tells the ECM what actual actuation pressure is at all times. Now, let's look at the path of oil flow through the actuation oil circuit. Oil from the engine lube pump supplies the needs of the engine lube system and the hydraulic pump for the fuel system. Oil is drawn from the sump and pressurized to lube system pressure by the lube pump. Oil flows from the lube pump through the engine oil cooler, through the oil filter, and then to the main oil gallery. A separate circuit from the main gallery directs part of the lube oil to supply the hydraulic pump. Oil flows into the inlet port of the hydraulic pump and fills the pump reservoir. The reservoir has 2 purposes. It provides oil to the hydraulic pump during startup until the engine lube pump can build pressure. And it provides makeup oil to the high-pressure passage in the cylinder head. When the engine is off and cools down, the oil shrinks. A check valve in the pump allows oil to be drawn from the pump reservoir to keep the high-pressure passage full. Do not remove the reservoir. The hydraulic pump is not serviceable and has no adjustments. The only serviceable components of the hydraulic pump assembly are the IAP control valve, fuel transfer pump, and pump drive gear. Oil from the reservoir flows to the inlet port of the piston pump barrel assembly. The rotation of the barrel assembly causes the pistons passing the inlet port to draw supply oil into the piston bore. The continued rotation of the barrel assembly causes the pistons to move back into the piston bore. As the pistons pass the outlet port, oil in the piston bore is pushed out of the outlet port under high pressure. This pressure ranges from 870 psi to 3,500 psi during normal operation. Oil then flows from the outlet port of the pump to the high-pressure oil supply passage in the cylinder head. The oil supply passage is actually a drilled hole which starts at the front of the cylinder head and extends through to the back of the cylinder head. This passage connects with each injector bore to supply high-pressure actuation oil to the injectors. Actuation oil from the hydraulic pump flows through the cylinder head to all of the injectors. Oil remains in the high-pressure passage until it is used by the injectors. Exhaust oil from the injectors is expelled under the valve cover and returns to the sump through the oil drain holes in the head. Now let's look at how actuation pressure is controlled. The hydraulic pump is a fixed displacement axial piston pump. The flow of this pump is directly proportional to engine speed, minimum pump flow is at cranking speed. The pump is sized to produce adequate flow at the two most demanding conditions: hot starting and low RPM lug. During hot starting, the engine is hot and the oil is thin. In these conditions, the pump must produce 870 psi during cranking, when engine speed is only about 200 RPM. At low RPM lug conditions, the injectors are using maximum fuel at peak injection pressure. This means they require maximum actuation oil flow at peak actuation pressure. This is a very demanding requirement when the engine is only turning at about 1200 RPM. Maximum pump flow is at high idle, which is about 2640 RPM. Under most operating conditions, the pump has much more flow than it needs. This excess flow must be returned to the sump to control system pressure. The Injection Actuation Pressure Control Valve, or IAP control valve, regulates the system pressure. It returns to sump the exact amount of oil required to maintain the desired actuation pressure. Let's briefly discuss how actuation pressure is controlled. There are two types of actuation pressure. First, there is desired pressure. Desired actuation pressure is the pressure the system wants for optimum performance. The ECM determines desired pressure using software maps and inputs from many sensors. Desired pressure is constantly changing based on the sensor inputs and changing engine speed and load. Desired pressure is only constant under steady-state conditions. The second type of actuation pressure is the actual system pressure of the actuation oil powering the injectors. The IAP control valve is constantly changing the amount of pump flow returned to the sump in order to make actual pressure match desired pressure. There are three components which work together to control actuation pressure: the ECM, the IAP control valve, and the IAP sensor. The ECM determines desired pressure based on sensor inputs and software maps. The ECM sends an electrical current to the IAP control valve to change actual pressure. The IAP control valve reacts to the electrical current from the ECM by changing the pressure at which the valve returns pump flow back to the sump. This valve acts like an electrically controlled relief valve. The higher the current to the valve, the higher the relief pressure. The lower the current, the lower the relief pressure. A lack of current to the valve results in a base relief pressure of 250 to 300 psi, which is the value of the valve's spool spring. The IAP sensor tells the ECM what the actual pressure in the high-pressure passage is. The IAP sensor reads actual pressure and sends a signal voltage back to the ECM. This process repeats itself more than 60 times a second in order to make actual pressure constantly match desired pressure. This constant repetitive cycle is known as the closed-loop control cycle. It is important to understand that the system is continually working to make actual pressure match desired pressure. This means that the IAP control valve does not need a precise initial setting to work properly. Since the closed-loop control system is constantly correcting, the ECM will send whatever amount of current is necessary to the IAP control valve to make actual pressure match desired. The IAP control valve regulates actuation pressure by returning excess pump flow to the sump. High-pressure oil from the outlet port of the pump barrel assembly flows through a passage in the pump housing and onto the outlet port at the back of the pump housing. The passage to the outlet port is also connected to the IAP control valve and the overpressure relief valve. The overpressure relief valve remains inactive during normal engine operation. This simple spring-loaded relief valve only opens if a major system malfunction occurs. A major malfunction could cause actuation pressure to greatly exceed normal operating pressures. Under normal engine operation, maximum actuation pressure is 3,500 psi. The overpressure relief valve is set at 4,400 psi. This valve should never open during the life of the pump unless an excessive level of pressure occurs. You should never adjust the overpressure relief valve in the field. It's set at the factory, and raising the relief setting of this valve could cause a failure and serious personal injury. Most of the high-pressure oil flow from the pump goes to power the injectors. Excess flow is returned to the sump through the IAP control valve. Excess flow from the IAP control valve flows upward through a U-shaped tube in the pump reservoir and out a drilled passage to the front of the pump. Drain oil flows out the front of the pump, over the pump drive gear, and down the engine front gear train to the sump. The U-shaped tube acts as an anti-siphon device. It prevents oil from siphoning through the IAP control valve and emptying the reservoir during long periods when the engine is not used. The IAP control valve is an electrically controlled, pilot-operated pressure control valve. It maintains selected actuation system pressure regardless of the engine speed, pump flow, and variable oil demand of the injectors. The basic components of the valve are the valve body, spool, spool spring, poppet, pushpin, armature, and the solenoid. The IAP control valve operates by using the variable electrical current from the ECM to create a magnetic field in the solenoid. This magnetic field acts on the iron armature and generates a mechanical force pushing the armature to the left. This force is transmitted through the pushpin to the small poppet valve. The magnetic force holding the poppet closed is opposed by reduced hydraulic pressure inside the spool chamber, trying to open the poppet. This reduced hydraulic pressure will increase until it overcomes the mechanical force of the solenoid and opens the poppet. The open poppet allows a flow path to sump for some of the reduced pressure oil. Returning part of the reduced pressure oil to the sump lowers its pressure. When the pressure of the reduced pressure oil falls below the magnetic force on the poppet closes again. With the engine off, there is no hydraulic pressure from the pump and no current to the solenoid from the ECM. The spool spring pushes the spool valve completely to the left, blocking the drain port. Approximately 870 psi, or 6 megapascals of actuation pressure are required to fire the injector during startup. To start the engine quickly, the actuation pressure must rise quickly. But pump flow is very low at startup because the hydraulic pump is being turned only at engine cranking speed. The ECM responds by sending a strong current to the IAP control valve. This holds the spool closed and blocks all flow to the sump until 870 psi is reached. At this point, the injectors fire. Once the injectors begin to fire, the ECM adjusts the current to the IAP control valve so that 870 psi is maintained until the engine starts. The ECM monitors actuation pressure through the IAP sensor, which is connected to the high-pressure oil passage. This is a closed-loop system. The ECM determines the desired pressure based on several inputs and sends a predetermined current to the IAP control valve. The ECM also compares the desired actuation pressure to the actual actuation pressure in the oil passage. It then makes adjustments to IAP control valve current to make actual pressure match desired pressure. Once the engine starts, the ECM regulates the current to the IAP control valve to maintain the desired actuation pressure. The IAP sensor monitors actual actuation pressure in the high-pressure oil supply passage in the cylinder head. The ECM compares actual actuation pressure to desired actuation pressure more than 60 times a second. If these pressures do not match, the ECM adjusts the current level to the IAP control valve to compensate. The IAP control valve allows infinitely variable control of pump outlet pressure between 870 psi and 3,500 psi. This system maintains extremely fast and accurate control of actuation pressure, providing excellent throttle response, improved fuel economy, and reduced exhaust emissions.